The year is 1971. The Cold War is raging, anti-Vietnam War protests are storming America, and the scientific community is crossing boundaries that would change medicine, agriculture, and society as we know it. Advancements and discoveries in biology are being made more rapidly than ever before, and it was clear that the world was gaining a new understanding of life. Scientists studying DNA started to explore the unknown: genetic engineering. Genetic engineering involves using lab technology to alter the DNA code of an organism, essentially editing life itself. One technology sparked intense controversy after its discovery in the 1970s: recombinant DNA, also referred to as rDNA. And the debate at hand was not only one of rDNA, but of the ethics of scientific research.
And so, in 1975, scientists from around the world gathered at the Asilomar conference grounds in California to discuss the question that would change science forever. Where should they draw the line with conducting rDNA research? The conference was a crucial step in establishing rights and responsibilities within the scientific community to manage scientific discoveries. By providing an ethical framework for scientists and confronting both the responsibilities of science to the world and the debate around the rights of the public in scientific decision-making, the Asilomar Conference set a historic precedent in addressing scientific controversy.
Recombinant DNA has become one of the most commonly used and influential biotechnologies of the 20th century. rDNA can best be understood through the example of insulin. Insulin is a treatment for diabetes, a condition where those affected lack the insulin hormone and therefore can't regulate their blood sugar properly. Initially, scientists harvested insulin from animals, but this was both unethical and unsafe.
So in 1978, scientists used rDNA to revolutionize insulin production. They isolated the insulin gene, inserted it into a loop of bacterial DNA, and let the bacteria produce large quantities of human insulin, which was then harvested, purified, and used for medical purposes. Recombinant DNA refers to the process of engineering pieces of DNA, creating a custom molecule.
Prior to the Asilomar conference, there were no set guidelines for working with recombinant DNA. It was so uncharted that scientists didn't know what guidelines to set. In 1971, biochemist Paul Berg was experimenting with rDNA, aiming to create vaccines, medications, and treatments for genetic disease. rDNA had incredible potential.
None of the experiments we had been doing would ever be done again because they were so primitive relative to what could be done with recombinant DNA.
Berg knew his experiments were hazardous. After all, he was working with E. coli, a harmful bacterium that can be deadly to humans. In addition to this, in the act of recombining DNA, he risked creating a cancer-causing virus that could escape his lab and cause an outbreak in the community.
As research continued, scientists began to face increasing pressure from the public, who were concerned about the ethics and safety of experimentation. People feared the practice of eugenics, careful selection and reproduction used to create a perfect race, much like how in World War II, Hitler tried to ensure the Aryan race was the only race.
Due to this increasing pressure and concern, in 1974, the Assembly of Life Sciences Committee called for a voluntary moratorium on two major types of rDNA experiments, urging researchers to halt their experiments until a consensus could be reached around their ethics and safety.
The moratorium, while not mandated by any organization, was internationally adhered to and effectively banned rDNA experimentation. The committee also recommended an international meeting to assess rDNA risks and set guidelines to proceed with research.
The committee would get their wish. On February 24, 1975, over 150 researchers from 12 different nations, 16 members from the media, and 4 lawyers met on the Asilomar conference grounds to discuss the hazards posed by rDNA research.
The conference lasted 4 days, in which key scientists such as Paul Berg, Maxine Singer, and David Baltimore would give presentations on their opinion on what restrictions should be set with rDNA research. By the end of the conference, the participants had agreed upon a strict set of guidelines detailing exactly which experiments could be continued with and which were deemed too risky. A few months later, these guidelines were officially put into effect when they were submitted to and approved by the Assembly of Life Sciences Committee.
In this aspect, Asilomar was a success. Scientists had accomplished exactly what they needed, creating a set of ethical guidelines to proceed with rDNA research. They had, to the best of their abilities, assessed the risk of rDNA experiments. But it was clear something more had happened. I shall never forget that incredible feeling of comradeship that developed that last night, Berg wrote in a letter to Maxine Singer and her husband just a few weeks post.
Asilomar was a symbol of responsibility and a symbol of ethicality. It was a significant time in history that scientists had gathered to confront the responsibility of their research. They knew that our DNA could save hundreds of lives, but they also knew that, as the only people with the proper expertise to set boundaries, they had a responsibility to the public to properly assess the hazards and ethics, and then and only then could they proceed with research.
This is exactly what Asilomar accomplished, setting a historic precedent for dealing with controversial scientific issues. The scientists at Asilomar had risen to their responsibility to keep the public safe above all else, something that had never previously happened in science.
I think the major legacy from Asilomar is that it showed that the community of scientists, although self-interested, were able to come together in a public-spirited way and face up to difficult issues.
Unfortunately, not everyone agreed with Asilomar's conclusions. In fact, many people were outraged at the outcome of Asilomar, fearing it would allow the creation of dangerous biotechnology.
Science for the People are here to try to bring the issues of this controversy to the public, to the people, because the people are at risk and are at benefit from the experiments that are being done with recombinant DNA.
Several critics, including Senator Edward Kennedy, argued that the moratorium was imposed and lifted by scientists, excluding the public from the decision-making process. Many believe the right to determine ethics on scientific issues should be shared between the scientists and the public. On the opposing side, scientists felt only they had the necessary expertise and right to decide our DNA regulations. In response to these criticisms, Asilomar attendee David Baltimore said, "We weren't arguing that Asilomar was the last word, but at that stage, we were the only ones that knew what was going on, and our whole point was to alert the public."
The Asilomar Conference highlighted the debate between the scientific community and the general public over who had the right to assess risks and set guidelines for hazardous technologies.
I think it has to be a collaboration between the scientists and society. I think it has to be a conversation that includes members of the general public.
While this debate may never be settled, Asilomar was the first instance of scientists acknowledging and addressing the concerns of the public, setting a precedent for how scientists should deal with backlash.
In fact, in the decades following Asilomar, the conference had become a model for dealing with controversial new technologies. In 2010, the Asilomar International Conference on Climate Intervention was held to discuss the hazards of climate engineering. Another conference, held in 2017, discussed the ramifications of AI and hosted influential engineers like Elon Musk. It resulted in the 23 Asilomar AI Principles, one of the earliest and most influential sets of AI governance principles. The Asilomar model is ideal for addressing controversial science and biotechnology topics, and it's necessary. Researchers are constantly discovering new and dangerous technologies. But perhaps the most notable of all has been the development of CRISPR-Cas9, a powerful new biotech with the ability to manipulate DNA with extreme precision. CRISPR poses substantial ethical concerns, even greater than those of our DNA. It could potentially enable the engineering of specific traits in a person, from eliminating genetic disease to changing the hair color of an embryo. And so, in 2015, scientists conducted a parallel Asilomar conference. In fact, some scientists from the original Asilomar conference, such as David Baltimore, were present at the CRISPR conference. They created a moratorium letter, just as the 1975 Asilomar scientists had, and held a conference in Napa Valley, California, to fully assess the risks and ethics of using CRISPR. A scientist present remarked, "The model of Asilomar still offers important lessons. We need to achieve broad agreement on specific standards and criteria for human germline genome editing research. Agreement that should include not only the scientific community, but also society as a whole." Throughout history, scientists have been seen as lofty figures, conducting experiments in sterile white lab coats above all law and morals. The Asilomar Conference shattered this perception, showing the public that scientists were, in fact, concerned members of society trying their best to fulfill their responsibilities.